Okay, in our last section of chapter 3, we are going to look at polynomial and rational inequalities. Now, we've obviously seen graphs of rational functions and things like that. So graphically, what we're talking about is if I have some kind of rational function, let's say it has a vertical asymptote and a horizontal asymptote, maybe it looks something like this. So what an inequality can tell us is it can tell us when it's bigger or smaller than a given number. Generally maybe 0. So if I take my line y equals 0, I can figure which values this thing is above or below that axis. So if you look here, like all these points have y values above that 0 and these values are above that 0. So you can find where it's greater than 0 or less than 0. You can really do it with any number. You can figure out it's greater than 1 or 2 or -7, whatever you'd like. Generally, we just focus on 0. So to do this, we can look at a graph, but we really want to start using what is called a sign chart. And a sign chart is the algebraic way we use to solve inequalities. Now, the reason we can't do just one method and just do kind of a straightforward thing with inequalities, there are lots and lots of numbers that are bigger or smaller than a given number. You can have quite a few. Whereas an equation, there's generally one number that's equal to it, so you're only going to have one solution. So these sign charts will allow us to figure out what is the variety and what's the range and the values of the numbers that we want to see for a given inequality. So we'll start with doing polynomial inequalities, in which, the polynomials, the things with the factors we talked about before. We know polynomial functions. We talked about in the beginning, chapter 2, x minus some roots with some multiplicities and things like this. This is obviously in factored form. And then we'll look at rational inequalities, which is the most recent thing we have, where we have asymptotes and holes and all that kind of good stuff. So we'll look at both of these types of inequalities. Now, when we talk about how we solve these algebraically, like I said, the big number we want to focus on is 0. So we generally don't want to have f of x greater than 2 or f of x less than or equal to 1. We want to basically have a 0. So we want to make sure we get a 0 on the right side. Now, for a polynomial inequality, we want to make sure it is in factored form, so we can find the zeros very quickly, like we did in chapter 2. So if it's not in factored form, we need to do all the things we did before to put it in factored form. Then we're going to find critical values. Critical values are just the zeros. So it's just what makes each factor 0. So like up here, it'd be -1, 5, and 3. And what we do when we pick these zeros, that is going to divide our number line into different regions. So bigger than one, less than another, and we'll see how that works. Then our idea is we'll pick a number in each region, and we will see if those are positive or negative. And we will either want positive regions if it's bigger than 0, or negative regions if it's less than 0. And then whatever regions we have, that's going to be our solution regions. So it seems like a lot of steps when you try them. We'll try some. They're really not so bad once you actually try to do them. So I have two of them here. One of them is already factored and one is not. So they both already have the 0 on the right side, which is good. So let's go ahead and factor this one since it has that 0. So this is a pretty easy factorization, because there are two numbers that multiply to -8, add to -2 are -4 and +2. We won't have this issue in the next one. So what I'll do is I'll look for my zeros. I want to see what my values that make this 0 are, and that's simply x equal 4 and -2, because that's what makes those two parentheses 0. So what I mean by a sign chart, what we're going to do is we're going to take a number line, something like this. So this number line, I'm going to put these two zeros on, which were -2 and 4. And what happens if you put those two numbers on, essentially we break this number line into 3 parts. I'm going to call this region A, region B, and region C. So what I'm going to do is I'm going to pick one number, any number in that region. So a number smaller than 2. And we generally call this a test point. So you can, sometimes I'll write over here test. So maybe I'll do negative 10. Doesn't matter. A number between negative 2 and 4. How about 0? And then a number bigger than 4, let's say 10. And now here's the weird part. So we're going to plug these numbers in. We're going to plug these 3 test numbers into our polynomial function, which is just simply x minus 4x plus 2. But I don't really care if it's negative or positive, or I don't really care the number. I just care if it's negative or positive. But if I plug it in, I get negative 10 minus 4 and negative 10 plus 2. So that's negative 14 times negative 8. Now, all I really care about is this is positive. I don't really care what the number is. You could certainly figure it out. But all I really care if it's negative or positive. Same thing for 0. 0 minus 4 and 0 plus 2. That's going to be negative 4 times 2, which is negative 8. But it's negative. That's all I really care about. And then for 10, 10 minus 4, 10 plus 2. That's 6 times 12, which is 72. Don't really care. All I care is that it's positive. So in region A, no matter what number you plug in, you would have got a positive. And in region B, no matter what number you would have plugged in, you got a negative, and C, a positive. So what I want to do now is I want to figure out, do I want positive or negative regions? Well, I want it greater than or equal to 0. So I want region A and region C. Now, region A is all the numbers smaller than negative 2. So that's negative infinity to negative 2. I will include it because it says equal to 0 and negative 2 is equal to 0. And then I will also include region C, which is 4 to infinity. So basically this region going 4 in this way, and this region negative 2 going this way, these are my 2 solution regions. Any number I pick in that region would make the inequality true. All right, so let's look at the second one, which, same idea. It's already in factored form. It's got a couple more factors. So it's already factored, so I can already see the zeros very easily. The zeros are going to be obviously 2, negative 3, and negative 10, because that's what's going to make them make each parenthesis 0. And it's less than 0 this time, so we won't include the endpoints. So we're going to make a big sign chart here. Now this one's going to have a couple numbers, negative 10, negative 3, and 2. Those are my zeros. Obviously put them in order. Region A, B, C, and D in this case. So we have 3 regions here. We want to see which ones are going to make them smaller than 0, because it's less than 0 in this case. So I'm going to pick a point in each region, so maybe something less than 10. How about negative 15? Something between negative 10 and negative 3. How about negative 7? Lots of good choices. Between negative 3 and 2, I'll go with 0, and then I'll go with 10, because that's a number bigger than 2. So I'm going to plug these numbers in. These are my test points, and I want to see what my value is when I plug them in. So negative 15 is going to be kind of weird. It's negative 15 minus 2, which is negative. Negative 15 plus 3, which is negative. And this last one, if you notice, the last one is squared, so it's always positive. So I don't really have to mess with that one because it's always positive. If you want to, you certainly can, but this is negative 17 times negative 12, which is a positive number, which is all I care about. I don't care about what the number is. I just care about if the value is negative or positive. Same thing for number 7. Now, if I want to plug in the last parentheses, I certainly could, but I don't need to. Negative 7 minus 2 is negative. Negative 7 plus 10 is, or plus 3, pardon me, is negative. Negative and negative is positive again, because it's negative 9 times negative 4 times some positive number. So we have 2 positives in a row in this case, which is kind of bizarre, but it's correct. 0 minus 2 and 0 plus 3. And again, I can ignore the last one because it's squared. That's going to be negative because it's negative 2 times 3. 10, we got 10 minus 2, which is positive. 10 plus 3, which is positive. So this is positive. So we actually have 3 regions in this case that work and 1 that doesn't. Now, the reason we still have to list it as 2 separate intervals is because we're not including -10. Remember, we said that we are doing less than but not equal to. So negative infinity to -10, -10 to -3, and then 2 to infinity. Those are those 3 intervals we talked about. Those would be the ones that would satisfy the original inequality. All right, when we look at rational inequalities, so some kind of fraction greater than less than 0, same idea. We are still going to do the same thing. The only difference now, instead of finding the zeros, we're going to find the solutions, which remember are what makes the top equal 0. And then what makes the denominator equal 0, and we're going to put those in our number line. That is the only difference. The only difference is doing the top and bottom and not just each parenthesis like in a polynomial equation. But the number line, everything else, very similar. So what we generally do is, this is a very simple one, this first one. We have x minus 7 over x minus 2. So the top being 0 is a 0. That's at x equals 7. And then the bottom, which in this case is an asymptote, but it could be a whole 2. What makes that 0 is 2. And I want to figure out whether that's less than or equal to 0. Very similar to before, I'll draw my number line. I will put those 2 zeros on, which are 2 and 7. Now, the one difference is I'm going to put a circle around 2, because 2 is excluded, so you can never have 2 be equal to. It can only be parenthesis in our interval notation. So I have region A, B, and C. So I'll pick a number in each region. So a number smaller than 2, let's go with 0. A number between 2 and 7, let's go with 5. And then bigger than 7, which is 10. And then same thing, I'll plug into my relation up here, my expression, and I'll see if it's negative or positive. 0 minus 7 over 0 minus 2. Those are both negative, so when I divide 2 negatives, I get a positive. It's positive 7/2, but I don't really care what the number is. 5 minus 7 over 5 minus 2 is going to be negative over positive, which is a negative. And then 10 minus 7 over 10 minus 2 is positive over positive, which is positive. Now the question is, which one of these do I want? Well, if you look, it shows here I want less than or equal to 0, so I want negative values. So the only negative region is this middle region. Now it says less than or equal to 0, so my final answer is going to be numbers between 2 and 7, because that's region B. I can include 7 because it's greater or less than or equal to, but I can't include 2. Because remember, 2 is what made the bottom 0. 2 can never be included in your solution set. It is an excluded value. If you remember when we did the function, we say x not equal to. In this case, x can't be 2, so you can't include it in your solution set. So it's just all the numbers between 2 and 7. All right, let's look at the second one. Already has 0 as well. All these have kind of had zeros. We'll look at the next one that doesn't have a 0 and how you'd have to handle that. It's a little more tricky. So what I'm going to do is I'm going to factor the top, because obviously I want to know what makes the top and bottom 0. So I obviously kind of have to have it in factored form. And this one's a pretty easy one because it's 2 numbers that multiply to -3, add to -2, -3, +1. Nothing tricky there. So my zeros, what makes the top 0, my zeros are going to be 3 and -1. And then my excluded values, what makes the bottom 0, is going to be 7. So I'm actually going to have 3 numbers on my number line. They're going to be -1, 3, and 7. So that's going to put me into 4 regions: A, B, C, and D. All right, so we'll put a test point for each one. So maybe I'll do my test point something less than -1. How about -10, 0, 5, and 10. These are numbers in each region smaller than -1, between -1 and 3, between 3 and 7, bigger than 7. And so then I'm going to plug it in up here into the expressions. Now we have 3 parentheses to plug them in this time. That's the only difference really. So -10 minus 3, -10 plus 1, -10 minus 7. So the top here becomes -13. So it's negative and negative. So basically we have a negative times a negative over a negative. So 3 negatives is a negative because it's positive over a negative. So that region's negative. Because again, I don't really care about the number. I just care if it's negative or positive. 0 minus 3, 0 plus 1 over 0 minus 7. This is a negative times a positive times divided by a negative. So it's a negative over a negative, which is a positive. 5 minus 3, 5 plus 1, 5 minus 7. Let's see. So we get positive, positive, negative. So the whole thing is negative. And then finally, I'm going to guess we're going to get a lot of positives. Positive, 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 plus, plus, plus. So multiply 2 positives divided by a positive is positive. So we have negative region, positive region, negative region, positive region. And if you recall from above, the original problem was greater than or equal to 0. So those are these positive regions. Now remember, this value was excluded. The other ones were 0. So if it's greater than or equal to 0, that's fine. So it would be -1 to 3. Those are both fine because those are zeros. Union, but I'll make sure I put a parenthesis on the 7 because I cannot include that. So if I pick any value between -1 and 3, including -1 and 3, or any number bigger than 7, and I plug it in my original, it will make a positive number. That is the whole idea behind using these sign charts. All right, let's look at this last example where the problem in this one is we now have a number that is not 0 here. We have the -3. So we'll have to use a little bit of algebra to clean that up. Now, the first part is very simple. I'll just add 3 to both sides, which will give me x minus 7 over x plus 5 plus 3. But now I have to make these two rational expressions one. I can't do this with two separate ones. I have to put them together. So what I'm going to do to add fractions, we have to have common denominators and such. So the common denominator here would be x plus 5. So I will multiply top and bottom by x plus 5. And that will all be greater than 0. So now we have to just clean up the top. So we'll get x minus 7 plus 3x plus 15 by just simply distributing the 3 all over x plus 5 greater than 0. So finally we end up with 4x plus 8 over x plus 5, or 4 quantity x plus 2 over x plus 5, all greater than 0. So I factored the 4 out just so it's easier to find the 0. I mean, you certainly could just set the top equal to 0. That's fine too. But I can see that my 0 is x equal -2. And my excluded value from the bottom is -5. So quite a bit of work just to get the 0 on one side and then to find the 0 and the excluded value. The rest is very similar. That's what we did before. Here's my number line. So I have -5, which is an excluded value, and I have -2. So I'll have 3 regions, A, B, and C, that I'll be dealing with. So I'll just pick a number in each region. So we'll make this -10, we'll make this -4, and we'll make this 0. So remember, I'm going to plug into the new expression, the one that's all simplified. So I'll get 4 times -10 plus 2 over -10 plus 5. That's a negative over a negative, which is a positive, because negative 10 plus 2 is negative 8. I'll have 4 times negative 4 plus 2 over negative 4 plus 5. That's going to be a negative over a positive, which is negative. And remember, we're looking for greater than 0 in this case. So far, just this region, not region B. And then finally, for 0, 4 times 0 plus 2. I'm assuming this will be positive over positive, which it is, which will make this positive. So I have two regions. Now in this case, it doesn't really matter for the excluded value and such because it's strictly greater than. So there's no equal to. So if there's no equal to, everything is just parentheses. So negative infinity to negative 5, union negative 2 to infinity. So that's just a quick little look at how we solve rational and polynomial inequalities. Obviously, if you have questions after you watch this, please let me know.